so for the bell work, we are supposed to do a limacon with an inner loop. So it contains the negative y-axis. What did you guys get? 3 minus what? Okay, there's more than one answer, by the way. 3 minus 7 sine of theta. And I am going to change, I got to go to my, I'm going to do zoom 6 for my window. That's a pretty darn good one. It goes right to negative 10. It's on the, contains the negative y-axis. Okay, and goes to negative 10. So that one works. Did anybody have another one? 4 minus 6. Four minus 6 sine of theta, is that what you said? If we graph that one as well, that one works perfectly too. Just has a smaller inner loop, a little bit wider as a limacon, okay? So there's probably several of them that worked, but that was somewhere around where you should have had it. Okay, good job on that. Because there will be some problems like that on your test. Can you guys handle that? Can you handle that? Okay. The test is not tomorrow. The test is Friday. Yeah. Hey, you guys, let me talk about that for a second. This is a pretty easy chapter, chapter 9, right? And I am going to give you lesson 9-3 today, and then we are going to take the tests. It's going to cover 9-1, 9-2, 9-3. I'm going to give the test on Friday. I will review first. I know there are sometimes people who like to slough on test days because they don't feel like they're ready for it, but I have never seen anybody do better by doing that because I review on test days. Come to the review. Don't miss it. Okay? And then we'll take the test. I would suggest preparing a 3x5 card with all notes we've had. How to plot points. What else was there? How to write equations. And today, what we learned today. Today is you're going to need some formulas. So today we're not going to review. We're going to review on Friday before we take the test. Okay? So before we do that, I want to correct the assignment. So get it out. So go to r equals, let's clear these two out. 4 sine of theta, right? By the way, did you guys all hit zoom 6 when you graphed it? So put it back to a kind of a standard window for polar equations. Probably because your window is changed. Hit zoom 6 when you put it in. That's because you had a crazy window, yeah. Guys, if you get a crazy window, it's probably because... Huh? That was 21. 21 is r equals sine of 4 theta. Sorry. Sine of 4 theta. Let's go back and do that again. Sine of 4 theta. Now, that one was really small. To get a better picture of this one, you guys, we're going to have to change our window, right? So we're going to have to bring it in so that we see the window has to go from like -2 to +2 and -2, +2 on each of the x-axis and y-axis. So I'm going to go down here to x min, and I'm going to go -2, x max +2, and I'm going to go down to y min -2, y max +2, and it was a rose, right? It was a rose that only had a radius of 1. That's what it was. A rose with a radius of 1. It's in the form of a rose, isn't it? And how many petals does it have? Yeah, I don't know whoever named these. Obviously didn't know his flowers very well. And I say he because a girl would have known, right? All right, okay. A daisy. That's definitely more like a daisy. Okay? So, well, all I did is I hit zoom 6, and then I changed my x min to -2, my x max to +2, my y min to -2, and my y max to +2, okay? So, you guys, this is positive 1 right here. See that? That's why I say it only has a radius of positive 1. This is negative 1, positive 1, and negative 1 on the graph. Okay? All right, that was problem number 4 on the assignment. Y equals sine of 4 theta. So it had a radius of 1. That's 1 in front of the sign, which we didn't write a 1, but since there's no number there, we know it's 1. Okay. Any other questions on the assignment? That was a pretty straightforward assignment, wasn't it? Okay, everybody exchange with your shoulder partner. If you don't have a shoulder partner, exchange with someone else. How many problems were there? Can anybody tell me? Was there 11? Count them, everybody. 11? So we're going to do number 3, 6, 7, 8, and 11. Okay. So the answers to these problems. Oh, I don't need to be recording this. Okay, this is lesson 9-3. And what we'll be doing here is today we're going to learn how to change polar coordinates, such as 5 comma pi over 3 right here, to rectangular coordinates. So you're changing, what we're going to do is change an r comma theta to an x comma y, give it a point. So we want to be able to know how to change a point from r comma theta. So if I gave you a graph, let me just kind of show you an example. Let's say I'm going to, you know what, I need to pull up a polar graph really quickly. Wait, where are my polar graphs? You guys remember where I put my polar graphs? I can't remember now. Polar graph, okay. All right. So let's say I have a point. These are every 15 degrees, right? So let's say I have this point right here. Wait, what was that point that I had on the last thing? 5 comma pi thirds, is that what it was? 5 comma pi thirds, okay. So I'm going to go to 5 comma pi thirds. So pi thirds. Where would pi thirds be, you guys? Right up here, right? 60 degrees. So that's right here. So 1, 2, 3, 4, 5. If I use the red lines as marking 1 unit each, this is the point 5 comma pi over 3. Now, we got that point by going out along this line right there, okay? And we turned that angle. This is theta, right? And by going out a distance, 1, 2, 3, 4, 5. That's how we got it, right? Now, to get an coordinate in rectangular coordinates, how would we do it? Okay? So to get a rectangular coordinate, I would go to the right. Let's do that in red. I would go to the right, and then I would go up, right? And there's x, there's y. By the way, there's r. Okay? So here's theta, and here's r. Here's x, and here's y. Yeah. Yeah, I can. It's 180. 210. Okay. 210 degrees. Well, because 7, yeah, I can picture it in all my head. I just have to think about it for a second. Well, 7 pi over 6 pi 6 is halfway around a circle. It's 180 degrees, right? And you just add in one more pi 6. 1 more pi 6 is 30 degrees. I know that pi 6 is 30 degrees, so I just go another 30 degrees off of 180. So that's what I do. Okay? All right. did you say, Jay? Or did you ask an intelligent question, or? I could do that one. Well, 360 plus 360 is 720. What was the number you gave me? 675. And so that is 675. What did I say? 720. That's 45 degrees less than 2 ways around. So that's going to be the same thing as a negative pi force, or which you could put as 7 pi force. All right. Okay. So, okay. Okay, back to this, you guys. X, Y. I've got to find. I just learned that this right here is pi thirds, and R is 5, right? Has everybody got that? I need to know those same coordinates in X and Y. How do you think we could go? How do you think we could find X and Y? Think about this. What was that? X. Think about this. What is R? You guys, what is R? Well, let's think of it this way. I know theta, right? Everybody look at this. I know theta. I want to know the opposite side of the angle, which is y. Let's say I'm looking for y coordinate. And I know the hypotenuse, right? What's an equation I could write? I could use sine. So I could go sine of what? Sine of pi thirds is equal to opposite over hypotenuse, right? And so if I times both of these by 5 to get y by itself, those cancel out and I get y equals 5 times the sine of theta. So all I have to do to find y is find the sine of theta and times it by 5, right? Or sine of pi thirds and times it by 5. Does that suggest a formula that we could come up with to find the y coordinate? Let's find the x coordinate first. What would I do if I wanted to find the x coordinate? Knowing I have this and this, and I want to know x. Cosine of pi thirds equals x over 5. Excellent. Times both sides by 5. 5's cancel out, and you get x equals 5 times the cosine of pi thirds. Okay, by the way, put those two, now, put those two in your calculator. Everybody take and put 5 times the sine of theta. But what mode do you want to be in? Oh, sorry. I changed that to theta. What is it supposed to be? Pi thirds. Go back to your mode button. You don't have to change to polar mode. You just need to change, make sure you're in, you need to make sure you're in radian mode. When you go to your degrees and radians, well, what's this in? What's this angle I gave you in? So you want it in radians. Okay. So everybody, put that in your calculator. Everybody in my family makes fun of me the way I say that. Now you guys are. What'd you get? 5 times the sine of pi thirds. 4.3? And what'd you get for, huh? 2.5? Is that what you guys all got? Okay, let's look to see if we right. About 2.5. Look, if you count this as 1 unit, this is 2 units, that's 3 units. And I probably drew my line a little bit crooked, right? It's probably right in there somewhere. It's supposed to be straight up. So that's about 2.5. And then if you count those distances the same right here, if I measure one of those distances, it's about 1, 2, 3, 4, and something, right? 4.3. So that's about right. Do we get that? Now this suggests a formula. What is a formula if I'm going to change, if I'm given polar coordinates, I want to change them to rectangular coordinates. What is a formula for finding y, and what is a formula for finding x? R times the sine of theta. What's the one for x? R times the cosine of theta. Notice, you guys, that up in the problem, R was 5. That's why we used 5 there. And theta was pi over 3, and that's why we did that. So to change rectangular coordinates, or polar coordinates to rectangular coordinates, you need to know those two formulas. But you really don't need to know those formulas because you could draw a triangle and set it up, couldn't you? Yourself, and remember it that way? Your right triangle trigonometry. Does that make sense? Okay, I want everybody to do this. Now that you have that, everybody with your shoulder partner. We're going to do a sage and scribe. The person on the left, I'm going to come down there, Jenny, you're going to do it for me. Oh, actually, McKay, come up, sit by Jenny really quickly for this. Bring your notebook. Okay, everybody, we're going to do a sage and scribe for this. You're going to do this problem right here. You're going to change that to rectangular coordinates. Person on the left tells the person on the right what to write. Person on the right can only write when that person on the left tells them. Go. Hey, you guys, the reason I drew a picture at first, some of you guys were asking me, do we have to do a picture again? The reason I did a picture here was to show you how we derived the formula. Do you understand what I'm saying? I showed you how we came up with the formulas using a picture, okay? Hopefully, I remember math a lot better myself when I know how it's derived, because if there's some things I don't remember about it, I just go back to thinking about this picture right here and I can remember it. Okay? I didn't actually have this formula memorized before I taught it to you. I just knew that if I had theta and r right here and I had x and y, I could come up with the formula myself, okay? Because I don't remember formulas very well. I'm one of those people that don't remember things like that, but I remember how I derive things. So some of you guys are better at memorizing them. Some of you guys are better at remembering how to derive things. I think if you're ever going to be really good at mathematics, you need to learn how to derive things. So that's why I showed you that method. So right here, we're going to use the two formulas. To find x, it's r times cosine of theta. And to find y, it's r times the sine of theta. Just like we know that the x-coordinate is related to the cosine and the y-coordinate is related to the sine. That's, if you're memorizing it, that might help you remember that. Okay? So all I have to do now, actually I'm going to let Sydney tell me what to do. Sydney, what am I going to do right here to find this? Okay, because r is 4, theta is 3 pi over 4. What did that come out to be? What did it come out to be? Point what? 1644? Huh? Is it 2 root 2? Well, okay. Well, let me ask you this. Cosine of, I know that 3 pi over 4, you guys, is over here. And cosine is a negative root 2 over 2, right? So I'm going to have 4 times a negative root 2 over 2. 2 will go into that twice, and so you get negative 2 root 2, like Sean was saying. What's negative 2 times root 2 come out to be as a decimal? But, hey, Sydney, you might want to check to see if you're in radians or degrees. You should be in what right here? Radians, okay? All right, I am going to now ask Andrew, this one right here. What am I going to do? Huh? Do you know how to do this? Okay, I am going to ask Lydia. Lydia, how do I do this? Did you say 3 pi over 4? Okay. Did you say, you didn't say times between sine and 3 pi over 4, right? It's 4 times the sine of 3 pi over 4, right? Okay, what did you get when you put that one in your calculator? You should have got 2 root 2, which is negative 2.8, or positive 2.82, right? How many of you had that? Okay. Now, since there's still some of you guys not sure, we're going to switch it around. This time the person on the right has to tell the person on the left what to do. Okay? Go ahead and do this one. Hey, you guys, I just changed it to degrees. No big deal, right? Yeah, but before you put in your calculator, what do you want to do? Change it to degrees. Okay, I'm going to ask someone. Eric, how am I going to find the x coordinate? No, not yet. Negative 13 times 70 degrees, right? Oh, cosine, yeah. We're talking about an x. X is related to cosines, right? Okay, how many of you guys got that? What does that come out to be? What? Negative 4.45. Okay. All right. McKay, how do I find the y? Okay, what do I get? 4 point what? 4 point what? 12.22? 12.22? Okay. Any questions on that? You guys all know how to change polar coordinates to rectangular coordinates, right? Now we've got to do the other way around. Now we have to change rectangular coordinates to polar coordinates. Okay? Now we're going to change negative 8, negative 12. Now I'm going to do another diagram right here. I'm going to use we'll use this thing right here. Okay, now negative 8, negative 12. Think about this, you guys. Negative 8, that's going to be off the chart. So we're going to use these small dots, these small circles. So I'm going to go negative 8, which is 1, 2, 3, 4, 5, 6, 7, 8 to right here. And down 12. Well, if I was going down 12, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And where these two lines meet, I can't see this very well, so I can make a vertical line using this. And I can make a horizontal line using this. So right here is where they intersect. So this is my point. Now I'm going to erase these two lines. Can you guys not? Thank you. I counted negative 8, negative 12. I just counted negative 8 along this line, negative 8, negative 12. I used the small circles. 1, 2, 3, 4, 5, 6, 7, 8. The reason I did that is because it would be way off the board if I... What was that? I don't think so. I think this is the first one right here. No, because if you count out this way, the same number of spaces. Okay, so now I have this point, and I'm going to draw a line back to the pole. Okay, And you guys, we have, you know what? We have this angle theta right here. And we have the distance negative 12 here, and this distance negative 8 here. And I'm going to erase this up to there. And I need to know r, right? Okay, now, you guys, I don't know if you guys, well, I'll explain that part in just a second right here. Let's talk about r first. What kind of triangle is this? Right triangle. I know two legs of it. Do I know how to find r? How do I find it? Negative 12 squared plus negative 8 squared r squared, right? Pythagorean theorem. Everybody remember that? That's the Pythagorean theorem. So, does this suggest a formula we can use to find r? What's the formula? Well, oh, just r. What did negative 12 represent? Jay, what did negative 12 represent? Okay, y or x. Okay, y in this case. And what does the negative 8 represent? X equals r squared. Guys, there's a formula for finding r, except for you're going to want to do what to both sides? Get r by itself. Square root it. So this is really the formula. Everybody write this down. R equals the square root of x squared plus y squared. And guess what? R, well, technically, I mean, r can be positive or negative. You got to look to see where your number is to determine. I mean, if I use the angle that goes out this way, opposite up here, this direction, then I want to use r to be negative, right? But if I'm going to turn my angle all the way around to here, it's going to be negative. However, well, we'll get to that part. Okay. So to find r, you guys, all you have to do is negative 12 squared plus negative 8 squared and take the square root of it. So everybody, in your calculator, I want you to hit the square root sign. Go. Everybody, hit your calculator, square root sign. Parentheses, negative 12 squared plus parentheses, negative 8 squared. And then hit another parenthesis at the end because you need the starting parenthesis on your calculator and the ending parenthesis. And so hit enter after that. And what do you get? 14.42 sounds about right. Okay? So r equals about 14.42. Now that's plus or minus, right? Okay, well, we're going to determine whether we need a plus or minus here in just a second. After we find theta. Okay, now let me ask you guys this. How are we going to find a theta given an x and a y? Tangent is equal to what? Opposite over adjacent, right? So we all know that tangent of theta is equal to opposite, which is y, over adjacent, which is the x coordinate, right? Now, I need to solve for theta. How do we get theta by itself? Tangent inverse. If I take the tangent inverse of both sides, I get theta equals the tangent inverse of y over x of y divided by x, right? So to find theta, all I have to do is the tangent inverse of y over x. Now, here's one thing about it. Tangent inverses won't give you angles in the second and fourth or third quadrants. Remember, it only gives you angles in the first and fourth quadrant. Remember that? From when we learned about tangent inverses a while ago? So, so what we're looking for right here is we're looking for an angle in the first quadrant, because What we're going to do is, you guys, anytime x, everybody write this down. If x is negative, add pi, or 180 if it's in degrees, 180 degrees if it's in degrees, pi if it's in radians. Because what we're going to do is, our angle's down here. We're going to get an angle, actually, that's opposite. We're going to get this angle up here instead of the angle down here. Does that make sense? We want to get the angle up there. So you're going to add pi to whatever you get. So everybody, on this one right here, y is negative 12, and x is negative 8. So everybody do the tangent inverse of negative 12 divided by negative 8. What do you get? Tangent inverse of negative 12 divided by negative 8. What is it? 56.31. And now 56 degrees is getting, I kind of said that opposite before. You guys, 56 degrees, 56.31 degrees. So we're getting the answer in degrees, I take it, right? Okay, so 56.31 is the angle up here. So what do I have to add to it? I got to add 180. So everybody add 180 to 56.31. Because anytime x is negative, you have to do this. What did you get? 236.31. So there is our angle, 236.31 degrees. And since I named this angle, I'm going to use the positive of the r value, so it's 14.42. So in other words, I turn an angle of 236.31, and then I go out 14.42. And there's the same point as we got by going negative 8 to negative 12 on the rectangular coordinate system. Got it? Okay, we're going to do one more of those. Okay, everybody do this one right here. I'm going to give you 5, 7. 5, 7. Now notice x is not negative this time, so you don't have to add 180 to it. Okay, everybody try this one. Find r and theta. Change these. Yeah, I'll go back to the other screen, but just write this down, 5, 7. Change it to polar coordinates. Okay? Sorry, I forgot to turn that on. Okay? So to find r, all I had to do is put 5 in for x, 7 in for y. Type square root of 5 squared plus 7 squared in your calculator. What do you get? 8.6. So r is 8.6. To find theta, all I had to do is take the tangent inverse of y, which is 7, over x, which is 5. So the tangent inverse of 7/5. Now, what mode are you guys in? Degree mode. So 7, 5 is going to be less than, somewhere between 30 and 45 degrees, I'm guessing. What? Did you get 54? Oh, 5, 7. No, it's going to be between 45 and about 70. 54 point what? 0.5? We'll just say 54.5 degrees. Got it? How many of you think you can do this assignment? Yeah. All right. Hey, you guys, do 14 through 25. If we have time at the end of class, I'm going to show you how to do 26 through 36, these last few. Because what I'm going to do is give you equations, and you've got to change those like to rectangle. Like if it's in, gives you an equation in a polar equation, you're going to change that to a rectangular equation. Yes, Sean. 23 is a prime number. Okay, that's your assignment.